Hey everyone, and welcome back to NextGen Manufacturing Nexus. Today we're going to dive into one of the most critical and honestly fascinating processes in all of engineering, aircraft certification. It's this massive invisible system that keeps every single flight you take incredibly safe. So let's get right into it.
So here's the big question, right? I mean, think about it. It's a massive, massive task, a puzzle of engineering that absolutely has to be perfect. So who are the ultimate gatekeepers? Who guarantees that safety? Well, for pretty much the entire world, that massive responsibility comes down to two powerhouse agencies. These are the real guardians of the sky, the ones who decide if a brand new plane design ever even gets off the ground.
So, on one side of the pond, you've got the FAA, the Federal Aviation Administration in the US. And on the other, you have the European Union's EASA. Now here's the fascinating part. They share the exact same goal, total uncompromising air safety, but their methods, well, they're surprisingly different, shaped by decades of different regulatory histories and, frankly, different cultures.
All right, so let's really get into the weeds here and look at how these two giants actually operate. We're going to put their fundamental approaches head-to-head to see how they prove a plane is safe to fly.
And right away, you can see this huge difference in philosophy. The FAA traditionally has a very prescriptive model. The best way to think about it is like a super detailed blueprint. You prove the plane is safe by showing you followed every single rule, to the letter, no exceptions. EASA, on the other hand, they're all about adaptive performance. They're looking at the bigger picture. They want to see that the manufacturer's entire organization is built to learn and adapt, proving safety through real-world, robust results, not just by ticking off boxes on a checklist.
And you can see this exact same thinking in how they handle data. The FAA's ASIS database is really focused on analyzing specific, individual safety events. It's about looking backward at what has already happened. EASA's Data for Safety program, though, is all about looking forward. It's designed for predictive insights, trying to spot trends and get ahead of potential problems before they even have a chance to happen.
Believe it or not, this difference in philosophy goes all the way down to the cockpit itself. So the FAA generally favors a challenge response checklist. You know, one pilot calls out an item and the other has to verbally confirm it. It's all about that explicit back and forth verification. EASA, though, often goes for a read and do approach during normal operations. The idea is to cut down on the cockpit chatter to create a smoother, more focused workflow.
Okay, so we've talked about these big ideas, these different philosophies, but what does it actually look like for a company like Boeing or Airbus when they're trying to get a new plane certified? To make this really concrete, let's zoom in on the FAA's process. For any manufacturer in the US, the entire process is basically built on one single document, Title 14 of the Code of Federal Regulations, Part 21. You can think of this as the absolute Bible for aircraft certification. It spells out every single requirement for certifying not just the aircraft, but the engines, the propellers, literally every part that goes into it. So Part 21 breaks it down into these key layers. First up, a manufacturer has to get a type certificate. That basically says the design is safe. Then they need a production certificate, which proves they can build that design over and over again, consistently and safely. And finally, each individual plane that rolls off the line gets its own airworthiness certificate. Now, EASA's process hits similar milestones for sure, but they put a much bigger emphasis on the manufacturer proving they have this super robust internal safety management system, basically showing that quality control is built into their DNA from the inside out.
And let's be clear, this is so much more than just paperwork. To meet these requirements, you need an absolutely staggering depth of specialized engineering knowledge. We're talking about bringing in experts with hyper-focused skills in hundreds of different fields.
I mean, just take a look at this list. These are some of the specialties for what are called Designated Engineering Representatives, or DERs. These are the technical wizards the FAA relies on to do the detailed work. We're talking about world-class specialists in metallurgy, in structural adhesives, in mechanical fasteners, even in the very specific physics of how bearings work. It means that every single component, right down to an individual screw, is being scrutinized by someone who is one of the best in the world at that one specific thing. It's incredible.
Okay, so let's pull back to the big picture again. You have these two different complex systems in the US and the EU. So, what does a global company like Boeing or Airbus do? Do they really have to go through this whole process twice for every plane?
Thankfully, the answer is no. They have a bilateral agreement with a bit of a mouthful of a name, the Technical Implementation Procedures, or TIP for short. And this agreement is absolutely critical. It essentially lets the FAA and EASA recognize and validate each other's certification work. Without it, the global aviation market just wouldn't function.
And this really is the bottom line. After looking at all these differences in philosophy, in procedure, and how they approach things, research shows that both systems are equally effective. Statistically, there's no difference in their safety records. They just take two different paths to get to the exact same destination, making our global skies as safe as they can possibly be.
But, of course, the challenge never stops evolving. The next huge frontier for these regulators isn't some new kind of engine or a new composite material, it's AI and machine learning.
Right now, regulators are already trying to figure out how on earth you certify these new technologies. I mean, how do you validate a machine learning algorithm that is designed to constantly change and evolve? How do you write the rules for an AI that helps pilots make decisions, or one that predicts when a part is going to fail before it actually does? These are the massive questions they're tackling as we speak. And that really leaves us with a final big thought. For decades, aviation safety has been defined by human performance and a set of fixed rules. But as the planes themselves start to become intelligent, the very definition of what airworthy means is going to have to change. The next chapter in manufacturing and aviation safety isn't in some distant future. It's being written right now.